So, Zhenis Buldirshin, highlights number 9, particle in a one-dimensional parabolic potential well. Growth plan. So, content of this template, the particle over box problem is a common application of quantum mechanical model to simulate system consists of particle moving horizontally within an infinitely deep well from which it cannot escape. The solution to the problem gives possible values of E and that the particle can process. E represents allowed the energy values X is a wave function which when square gives its probabilities located the particle at certain position within the box at a given energy level. Table of the content we now talk about the first is the define the potential energy, solve the Schrödinger equation, solve the wave functions, and solve the allowed energies. So the first is define the potential energy. Define the potential energy is a zero inside the box, V equal to the zero for, and that goes to infinity at the walls of the box. We assume the walls have infinite potential energy to ensure that the particle has zero probability is being at the walls or outside the box. Doing to significantly simplifies our later mathematical calculations as we employ the boundary conditions when solving the Schrödinger equation. And the parabolic potential equation is the lowest energy level is zero. This violates the uncentrality principle. And the wave function solutions are psi n equal to the h n e ax squared divided 2, where h and x is a harmonic polynomial of order n. The contrast to the particle of a box where the oscillations wave functions is a sinusoidal curve. In this case, the oscillatory behavior is due to polynomial which dominates at small x, and the exponential tails of provoked by the Gaussian functions which dominates at large x. In the speech, we say that it's a potential energy, it's a Vx, and in this E0 and the positions, and the minus A is the expectable positions. And the next is analysis of the parabolic potential energy well. And so in this speech, we see the wave functions formulations, and the energy levels are given by En equal to Zn plus 1 divided 2h and T divided M and equal to the N plus 1 divided 2h omega. And the 0-point energy is called the Heisenberg limit, A equal to the A0 equal to the 1 divided 2h omega. And classically, the probability of finding the mass is the greatest at the ends of motion and the smallest at the center. And that's proportional to the amount of the mass spent on each position. And the contrary to the classical one, the largest probability for this lowest energy state is for the particle to be at the center. And the next is the parabolic potential well. So the wave function solutions are psi n equal to z. We see that this formulation, and we see the hn is a harmonic formulation of order n. And the next formulation is the wave functions. For example, psi 3x equal to the a divided p, 1 divided 2, 1 divided 3ax times ax squared minus 3. And in the speech, we see the wave functions. In the speech, we see the psi 2, psi 1, and psi 0 in this another functions of this picture. And the analysis of the parabolic potential well. So in this picture, we see the analysis of the parabolic potential well, and energy given by En equal to the N divided N plus 1 divided 2x T divided M equal to the N plus 1 divided 2H omega, and 0 point energy is called Heisenberg limit. And the next is the conclusion. Notice that the number of nodes placed where the particle has a probability of being located increases, we increase energy, and also note that actually energy of particle becomes greater and the quantum mechanical model breaks down as the energy levels get closer together and overlap and forming a continuum. This continuum means the particle is free and can have an energy value, and as such, key energies, the classical mechanical model applied as the particle behavior like continuous wave. Therefore, the particle in box problem in an example with particle duality. For example, in this graph, we see the psi 2, it's 0 in the graph in this formulation is it's a parabola, 3 graph, which is a parabola, psi 0, and in the picture is AX. This for the particle in a box problem in an example of wave particle duality.